Okay, so we're in sinusoidal functions and we're doing topic 2. So we're going to explore how changing the values of a, b, and c and d in a sinusoidal function affect the graph of the function. So the first part is an exploration. In class, we're going to take a look at what happens. We're going to use a GeoGebra demo. The exploration link, it's actually it's a Desmos calculator, is given, and then you're basically going to put in various values for the given equation. Y is equal to a sine bx plus c bracket plus d, and just by changing various sliders, and you can use this applet. Like I said, I've included a link to use Desmos, and we're going to look at that. You can also use this with your graphing calculator just by changing values. If we're using it with the graphing calculator, you might want to start with your equation y is equal to sine x, and these as your windows using degrees. What you're going to notice is that as we change various parameters, what happens is we start to see various changes to the function. For example, if you experiment with changing the parameter a, so here we're changing parameter a in y equals a sine x, what we notice is that if we're starting with a graph that looks as follows, and I'll graph it in black, so we have our basic sine x, and we start to change a, what happens is we keep the nodes on the midline, sorry about my drawing, and we start to get a changing of the amplitude. Okay, so by changing a, we get a variety of those amounts, and the amplitude changes. It might even flip over as we change a into negative values. Okay, so black is the original, blue and red are what happens, and you get a variety depending on what happens. So changing a changes the amplitude. And of course, it's cool to see it. So this is really something that you probably want to play around with, either on your calculator. You could put it in your calculator and change values for a, like put it in as 1, as 2, 3, -2, -3, and you'll see what happens. But you'll also notice, and you can graph them against the base function, that it keeps these points of contact do not change. Now, if we experiment by changing parameter b in y is equal to sine b of x, so we're going to change those, and so what happens then, so you probably want to play around with that, put that in your calculator, and you're going to shift and change your values for b. So again, starting with the original sine function in black, and then what happens when we change b, sine of bx. And what you'll notice, dun, 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 is that everything stays the same except the period changes. So red, it might be getting tighter together, or it might expand out when b gets greater than 1. So what happens when we change B? Changing B is it changes the period. Okay, so we still have the same amplitude, but the period shifts and changes. Okay, it kind of looks like a slinky, right? Next, we're going to experiment with changing C in y is equal to sine x minus c, or x plus c, depending on how you put in your calculator. How does changing C affect? Okay, so you put that in your calculator, and you're going to experiment with that. So changing C. So again, let's draw our basic graph in black. So we change C, so we have our basic sine function. And C, what starts to happen is we start to get a horizontal translation, right? So the shape is very much the same, but we're getting a horizontal shift or change to it. So what might happen is it will echo that same shape, but it'll be shifted back and forth. So changing C, we get a horizontal translation. Okay, interesting. Very hard to get it back to 0. And finally, we're going to experiment with changing the value of D in y is equal to sine of x plus D. And how does changing D affect the graph? So we have our graph, and what we're going to notice is that if we change D, we get a vertical translation. Okay, so this is going to affect our midline, and it's going to change our range. So changing D, vertical translation. So this is going to change the range, because it's going to shift it either up or down, and the midline. Okay, so you can see how changing those parameters, hopefully if you go in and try that out, can give you some different things. Now there's obviously a pattern to how this affects things, right? So we can take those points, those variables, and we can draw some conclusions. So any sinusoidal function can be expressed as y is equal to a sine bracket b of x, or b times x plus c close bracket plus d. And remember, we've just looked at what each one has done, and you can, whether you did it on your calculator or you tried out a simulator to kind of test it out, we can kind of see what's happening. So first, this is what we find out from it. Parameter A is the amplitude. So whatever value for A is going to give you the amplitude of your sine function. B affects the period. So B is the number of cycles in 360 degrees, or 2 pi. So B is equal to 2 pi divided by the period, or 360 divided by the period. Obviously, it depends on whether you have it in radians or degrees. Okay, clearly the first one is for radians and the second one is for degrees. So if you have a value of 3 for B, then your B will be equal to 360 degrees divided by the period. So you would rearrange and solve for B. And we'll do some practice with that, obviously. Now, C affects the horizontal shift, and it's also known as our phase shift, okay, horizontal shift. D is the midline or the median, so whatever D is, it's going to tell you where the midline or the median is, and it's known as the vertical shift. The equation of the midline, therefore, is y is equal to D. Okay, so you can tell a lot of information. I always like it when we have an equation for a function where we can actually mine information about the characteristics of the function from that equation. And this is certainly one where we can do that. Okay, so many characteristics of a sinusoidal function can be calculated using the parameters a, b, and d. Okay, so amplitude is a. It's the maximum minus the minimum over 2. The period, well, we can tell the period either using this formula or this formula, depending on whether it's in radians or degrees, right? So the formulas there are given. The vertical shift, D, is equal to the maximum plus the minimum divided by 2. That looks familiar. We've seen that formula before, haven't we? So that's also telling us our, is it not our midline? Right? Midline. Oops. Let me write it in midline. So you don't even have to do that calculation if you have D as part of your formula. The maximum is going to be D plus A. The minimum will be D minus A. Yay. And the range, well, y will be greater than or equal to the minimum, so D minus A, and it'll be less than or equal to the maximum. So let's see where that's come from, right? So this is your maximum, and this is, oh, sorry, wrong way around. Oop. Oop. Let's highlight this, reverse. So maximum and minimum, right? Min, max. But all those pieces of information are available in the formula given. Okay, so let's play around with that. Okay, determining the characteristics of a sine function based on its equation. So consider the function. Y is equal to 2 sine 4x plus 1. For x is equal to 0 to 360 degrees. That's our domain. Okay, it says describe the graph of the function by stating the amplitude, the equation of the midline, range, and period. So amplitude, from our previous page, our amplitude is equal to A. A is equal to 2. Let's write that equation, right? Let's just write it out so we have it. Y is equal to A sine bx plus c plus d. Okay, so amplitude A is equal to A. The equation of the midline, well, we already talked about this, didn't we? The midline, if you look on the previous page, is y is equal to d. So y is equal to 1, right? And if it helps, we can write this out, like from this equation. A equals 2, B equals 4, D equals 1, okay? C would be equal to 0. We could write that as well, okay? All right, so we have our amplitude. We have our midline. Okay, what else did we need to know? The range. Okay, our range from our formula, y is equal to Well, the first one is d minus a. So d minus a is -1, right? Greater than, equal to. And then the second one is d plus a. So 2 plus 3, 3. And then y is yer. Okay, so that's just using the formula from the previous page. Okay, so that's the third thing we needed to find. And then we need the period. The period, looking at our previous thing, is going to be equal to 360 divided by b. So 360 divided by b equals 90 degrees. So all of that information, without even sketching anything, we just mined out of the equation as given, okay? Now, the expression sine x plus d indicates that sine operates only on x. To indicate that sine operates on the expression x plus c, you have to use parentheses, right? So we'd have to use sine x plus 3. There is no parentheses here, so c is equal to 0, okay? Explain how you could use technology to verify your solution. Well, if you put this in your calculator, I'm going to do it with a different color because I don't like that color on the screen. 2 equals sine 4x plus 1, and you could graph it with your calculator. Find the max and min. So then once you have your max and min, you can find your midline, you can find your amplitude, you can find your period using your x-intercepts. So you graph it with the calculator and look for those points, okay? Determining the characteristics of a sine function based on its equation. So again, I'm going to write out our equation, our standard, so to speak. Y is equal to a sine bx plus c plus d. Now, here we have the equation. Y is equal to 3 sine x minus 14, and x minus 14 is in brackets. We're given our domain in radians, so we're going to take that into consideration. So let's find our values for a, b, c, and d from this equation. A is right there, is it not? A equals 3, b equals 2, c equals -14, and d equals 0. Okay, so that's our mining our information to start. Now it wants us to find the rest of the information. So it wants to find us to describe the graph along with the range and the period. So we want to find, we've stated the values, and we want to find the range. So the range, using our formula, y, so it's going to be d minus a, so 0 minus a, so -3, greater than equal to, and then d plus a, so 0 plus 3, and then y is in the set of reals. Okay, so we've got our range, and then our period, well, this one is in radians, but that's okay, because the period is going to be 2 pi over b, so it's 2 pi divided by 2, so it's equal to pi. And remember, just remember that it says, if no degree symbol is present in the equation, then we assume we're measuring the domain in radians. So when we saw that domain, we said, oh, it's in radians. Now we could find out the rest of the information. It hasn't asked us to, but we could. So we could find things like, we could find the amplitude. The amplitude we know is equal to A, so it's 3. We know the period. We could find our maximum. It's from our range, right? Our maximum is 3 and our minimum is -3. That's going to tell me that my midline is going to be equal to halfway between those two, right? Our midline is also equal to D, right? D is equal to 0. So we can find quite a bit just from that information, okay? So it's really about mining that and finding those things out. Okay, matching graphs to equations. So sometimes you're going to get a graph and it's going to say which graph goes with which. So we've got 2 graphs here and we've got 4 different equations. So we want to know which graphs are which. Now remember, we can look at these graphs and figure some things out. Here I have a max of 5 and a minimum of -3, right? My period goes from 90 to 450. So my period is 450 minus 90, which is 360. Okay, so that would tell me that B, since B is equal to, 360 divided by 360, right? Because it's 360 divided by the period. So B must equal 1, okay? So that would tell me that I only have 2 options, right? From the given graphs, because it can't be 2 or 3, right? So it's going to be either 1 or 4 because B equals 1. I can also find that D is my midline, and if I'm looking at this, my midline goes along 1. So D equals 1. So that tells me that this is for graph 1. I can double check by checking my amplitude. My amplitude here is 1, 2, 3, 4. So A equals 4. So that is consistent. So A is equal to 4. B equals 1. And B equals 1 and D equals 1. So that matches up with graph 1. Okay. So just basically analyzing the picture and then finding what works. So here, graph number 2, looking at what I have. So I go, my minimum is -1, my maximum is 5. So that means my midline is going to be at 2, right? That's halfway between them. Is it not? 1, 2, 3, 1, 2, 3. Yeah. So that means D equals 2. Okay. My period, sorry, folks. Almost there. My period, well, it goes from, I don't have a nice even thing. Goes from there to there. So half between 180 and 270 and 360 and 450. So looking at that, 540 minus 270. So divided by 2 plus. So my period goes 360 minus, and then 270. So my period, no, did I do that right? I don't think I did that right. No. I'm just, I'm figuring out the period, right? So that is at, where am I here? So this is at 4:05. And this is 225 degrees. So the period is going to be 4:05 minus 225. So it's going to be 180 degrees for my period, right? So the period's 180. B equals 360 divided by 180. So B equals 2. So I have D equals 2 and B equals 2. And my amplitude is 3. So I'm looking for y is equal to 3 sine 2x plus 2. So I'm looking for this one here. Okay, so this is graph 2. So just a little bit of analysis to kind of get you where you need to go. And sometimes you have to do some scribbling and some figuring out. So which of these graphs represents graph 1? I've done the analysis. It's I. We already know that. And which one represents graph 2? It's 3. Again, I did the analysis. And it's just basically you're looking for what can you tell from that graph regarding A, B, C, and D. Remembering things like, you know, A equals amplitude. That's the easiest one probably. D equals your midline. And then using the period to find B. Okay, so you can do that kind of work to kind of help yourself through that. Okay, okay, let's scoot along. Oh, page 30. I was going to do page 28 again. That would be wrong. So let's look at page 30. Determining the equation of a function given the characteristics. Create a sinusoidal function of the form y is equal to a sine bx plus d that has the following characteristics. The range is -3 to 4, and it has a period of 6. So let's take a look at what we know. Remember, this means this is our min, and this is our max. Okay? So our amplitude, which is equal to A, will equal our max minus our min divided by 2. So 4 minus a -3 over 2. So that will be A will be equal to 7 over 2 or 3.5. And yes, you can have decimals. So we have an A value. Now let's find our B value. B, we want a period of 6. So we're going to put it in radians. So it's going to be 2 pi over 6. So B will be equal to pi over 3. And that is totally fine as well. And then C, or D, sorry. D, remember D is our vertical shift, and it is equal to the max plus the min over 2, and we have those. So we have 4 plus -3 divided by 2, so that works out to 0.5. So we take all of those, and we're going to put it in this form. So we're going to get y is equal to 3.5 sine, and then we're going to have pi over 3 for the b, x, and then plus 0.5. So in this case, we're putting it in radians for our b value. It's easier to kind of work with it that way, to express it in that form. Okay? And the big thing is that it says the period is 6. If it had given us our period in degrees, then we would find out B using 360. Okay? Example 5. Solving a problem using a sinusoidal function. The far north is called the land of the midnight sun for a good reason. During the summer months, in some locations, the sun can be visible for 24 hours a day. The number of hours of daylight in Iqaluit Nunavut can be represented by the following function. So we're going to use this function here, which has our A, B, C, and D value, where X is the day number in the year. How many hours of daylight occur in Iqaluit on the shortest day of the year to the nearest 10th? Well, if we're looking for the shortest day of the year to the nearest 10th, we're going to be analyzing this equation, or we're going to be using this equation to figure it out, right? So, let's put in this equation in our calculator. 8.245 sine bracket 0.0172x minus 1.393 bracket plus 12.585. Okay, and we're graphing it, and I think I need to put it in radians. I just got to check my window. Well, I'm going to go from 0 to 365, because that's how many days there are in a year, right? Let's think about what we know. This is our B. We have our A. And our maximum and minimum. So this is giving us hours of daylight, right? On the shortest day of the year, so it's going to be the minimum, correct? So it would be D minus A, 12.585. Sorry, my calculator's just doing funny things for me right now. My apologies. There we go. 12.585 minus 8.245, and I get 4.34. So this is basically D minus A, because we're looking for our minimum, right? Okay, and it wants it just to the nearest tenth, so 4.3. How many daylight hours does Iqaluit get on February 22nd? January has 31 days. Round your answer to the nearest tenth. So we're going to make X is equal to, well, it's going to be 31 plus 22, right? Oops, I minus, that won't work. So we're looking for day 53. So let's calculate that, right? So 8.245 times sine of 0.0172 times 53 minus 1.393 brackets, close those brackets, plus 12.585, and I got the wrong answer. I'm just going to check what I'm in. Do I need to be in, I need to be in radians. Sorry, guys. I have it in degrees, and that will give me the wrong answer. So clear 8.245 times sine 0.0172 times 53 minus 1.393 close bracket plus 12.585. And I get, when I calculate that, and so just make sure you're in radians for this, because otherwise you'll get the wrong answer. I get 8.767, which to the nearest tenth would be 8.8. Okay? What is the period of the sinusoidal function to the nearest tenth? Explain how the period relates to the context of the problem. Well, the period is 2 pi divided by b, okay, which also equals 365 days, right? B, 2 pi over 0.0172. So if we do that calculation, 2 times pi divided by 0.0172, I got 365.30 ... So basically, this is telling us how many days in a year. Okay. What is the first day that a coloret will have 16 hours of daylight? So we make y equals 16. And this happens, we can do an intersection. And what we find is on day 106. So it's mid-April. Because 106, subtract 31 for January, subtract 28 for February. 30 days has September, April, June, and November. Subtract 31 for March. So yeah, it's about halfway. It's like around, it's like April 16th. Okay. And you can do that when you're graphing. You need to make sure that you are on radians to get that. For my range, or my domain, I put in 365, but I shouldn't. I should have put in I'm just trying to think it through because I'm just getting the weird. I'm going to have to figure out my windows for that. That's a little trickier. Okay, I'm going to think about that and get back to you. Okay, well, if I'm actually, I'll try this. No, same thing. Oh, okay. Anywho, it's a bit of problem solving there in terms of figuring that out. But the cool thing is that you can, and you can use the information given. You might have to do a little more thinking with some of those real world problem solving. Any sinusoidal function can be expressed in the following way. Y is equal to A sine bracket bx plus c, close bracket plus d. A, B, C, and D are parameters that affect the characteristics of the graph, okay? A is the amplitude. B, it affects the period. And the period is either 2 pi divided by the period, or B is either 2 pi divided by the period, or 360 degrees divided by the period, okay? C affects the horizontal shift, up and down, and D is the midline or median. So it's kind of nice that the equation of the midline is just given to you with D, okay? Many characteristics of the sinusoidal function can be calculated using these parameters. So be familiar with these. You can find the amplitude because it's equal to A. It's also the maximum minus the minimum over 2. You can find the period because it's either 2 pi over B or 360 over B. As B increases, the period decreases. Vertical shift. D, the maximum plus the minimum, divided by 2, so you can use D to help you find that. And as D increases, the vertical shift increases. And you can find the maximum and the minimum if you know D and A. You can also find the range, because the range goes from the minimum to the maximum, right? So it's just filling them in. The expression sine x plus c indicates that sine operates only on x. If there's no brackets, then it's just sine x, and that means b equals 1, okay? And c is actually your value for D. To indicate that sine operates on the expression x plus c, you use parameters, okay? So, parentheses. So be careful about that in terms of identifying c, okay? And we have a weird little block there. So I've got to think about that one. I'm going to put that domain in so I can solve that problem, and I will get back to you, but